Welcome to the video lesson of the second chapter of 12th physics. The topic which I would like to cover in this video lesson will be the capacitors and capacitance. The content we covered in this will be introducing the capacitors and their types, the meaning of the capacitance, the basic construction, grouping of the capacitors, namely in the series and parallel combination, energy stored in the capacitor, and their uses. First of all, what is a capacitor? We have learned about the potential, and if we want to raise the potential, then means the charge is to get stored as much as possible. So the device which can store the electric charge more and more is the capacitor. It consists of the two plates which are separated by non-conductive region, or in the region between the two plates some dielectric medium can be placed. We have the variety of sizes and shapes of the capacitor. Symbolically, it is given by the two parallel lines. And if you want to have the variable capacitor, these parallel lines are crossed. There puts arrow. Crosswise arrow is put on these two parallel lines. In the types of capacitor, we have parallel plate capacitor, spherical capacitor, cylindrical capacitor. Capacitance means the ability to store the charge. Ability of what? Ability to store the charge. C is defined as mathematically Q upon V. Q is the charge on the plates of the capacitor, and V the potential difference between the two plates. This coulomb per volt is the farad. Farad is the SI unit of the capacitance, and smaller units, in smaller units we can have the microfarad, nanofarad, picofarad. Basic construction can be shown this way. Two plates, metallic plates, dielectric in between. Here it is with a green color. Then the charge can be stored on the plates of capacitor. Right? Potential is raised from zero when it is uncharged and giving charge onto the plates and decreasing the distance between the plates and putting dielectric medium between the plates. The capacity of this system of two plates can be raised. We can have the grouping of capacitors. We want to have less or more capacitance, then we combine the capacitors. Here are shown the n capacitors combined in parallel. First of all, in parallel, that is across the plates of capacitor, what is there? The potential or the voltage remains the same. Charge is not same. Charge gets distributed amongst the plates of capacitor depending upon the capacitance. Using the formula Q is equal to C into V, and V is common to all, we can have the total capacitance as C1 plus C2 and up to Cn. So if we want to have more capacitance, then the capacitors are combined in the parallel. Also, they can be grouped in the series. In series, the charge on each capacitor is the same, but the potential is different. And definitely we will have for potential across each capacitor, if V1, V2 and so on to Vn say, then we will have V is equal to V1 plus V2 plus V3. and putting the value Q upon C1, Q upon C2, Q upon C3 and so on, because Q is the same on each capacitor plates. So we will have this. And for equivalent capacitance, we will have 1 upon C is equal to 1 upon C1 plus 1 upon C2 up to Cn. That is the effective capacitance when the capacitors are in series is going to be less than the least capacitance in the circuit. Capacitors this way can be joined in the series and parallel mode. We can have the uses of capacitors as batteries. Charge can be stored onto them. Sensing devices can be used to separate AC and DC, because capacitors do not allow AC or DC. DC is not allowed to pass through them. And in audio system also the capacitors are used. The energy can be stored in the capacitor and can be expressed this way, that, or if they are connected in the series, then Q square upon 2C, and when in parallel then we can write 1 upon 2 CV square.